How does event-driven programming work in JavaScript? Breaking news in the world of web development. The question on many developers' minds right now is, how does event-driven programming work in JavaScript? With the increasing demand for interactive applications, understanding this concept is essential. Let's break it down in a straightforward way. Event-driven programming in JavaScript means that the code responds to events like user actions, such as clicks or typing. It can also respond to system events or messages from other parts of the program. Instead of executing code in a straight line from top to bottom, JavaScript waits for these events to happen. When an event occurs, specific functions known as event handlers or callbacks are executed. The key player in this process is the event loop. JavaScript operates on a single thread, which means it can only do one thing at a time. The event loop helps manage asynchronous tasks without blocking the main thread. It continuously checks two important structures, the call stack and the event queue. The call stack is where synchronous code runs right away. On the other hand, the event queue holds asynchronous tasks like timers and network requests until the call stack is clear. When an event happens, its callback function is added to the event queue. The event loop then takes tasks from the queue and executes them once the call stack is empty. For instance, when using the setTimeout function, the timer callback does not run immediately. Instead, it gets queued up. The synchronous code runs first, and only after that does the event loop execute the timer callback. Consider this example. You have a console log that says start, then a setTimeout that logs timeout, followed by another console log that says end. The output will show start, then end, and finally timeout. This illustrates how JavaScript handles asynchronous events without blocking the main execution thread. In environments like Node.js, this event-driven model pairs with non-blocking input and output operations. Incoming requests are placed in the event queue, allowing the event loop to delegate non-blocking tasks like file reads or database queries. When these tasks finish, their callbacks return to the event queue for execution. This design allows Node.js to handle many operations simultaneously without needing multiple threads. In summary, event-driven programming in JavaScript relies on the event loop to manage asynchronous events. It queues callbacks and executes them when the main execution stack is free. This enables responsive and efficient code execution, making it a vital concept for modern web development.